Okay, so last time, just a quick review, we did explain when we want to elicitate probability from another person or elicitate from your own mind. How would you do that? And the first method could be a verbal expression of probability, but we talk about why that could be problematic, right? Because first, to start off, different people may have different probability measurement, and even the ranking could be different. So some people think probable is more likely than unlikely, but some people think that unlikely is more likely to be than probable. Okay, and it could be influenced by context. Like right now, if you ask people if someone is sneezing and coughing, then they're seriously ill, your guess would be much more likely that he got a COVID-19 rather than an influenza, which might actually be wrong. Okay, so different expression in this case could lead to different conclusion, for example. And so this is a brief understanding. Okay, so but even there's another issue here. So estimation of the probability often are not coherent in that they do not conform to the law of probability. So basically, if you ask people what is the probability of event A and what is the probability of event B, and then you ask him what is the probability that event A and event B will both happen, and suppose you somehow know that event A and event B are independent events, then you should, the three number that you just asked should follow this rule. Okay? Or even a simpler one is that if you ask someone what is the probability that tomorrow will rain, and then later you ask the same person what is the probability that tomorrow will not rain. Together, these two probabilities should add up to 1 because they are disjoint event. But sometimes people just give you a number that add up to less than 1 or greater than 1. So this is a problem. But this is just the minor problem, okay? Because even if your estimation or the estimation other people gave you are coherent, that doesn't mean they are correct. Okay, for example, if you use this example. So suppose this person tell you that PA is 0.5, PB is also 0.5, and PA intersect with B is 0.25. Okay, and so this is coherent, right? Okay. Are people following me? So do people understand what I'm saying? This is coherent. Okay. But for example, the other person tell you that PA and PB are both 0.3 and PA intersect with B is 0.09. Is this coherent? Yeah, right? But since the number here and here and here and here are all 4 different numbers, right? These two should equal to each other. These two should equal to each other. But they're not. But they're both coherent, right? That's what I'm saying here. Because multiple estimation could be coherent. Okay, so coherent is just like a base need. It's not something that that guarantee you are correct. Okay, I can only say that if your estimation that you gave me are incoherent, then it definitely is incorrect. But conversely, you cannot say that they are coherent, they are thus correct. Okay, there are 2 different logic directions. So you need to take a note. Okay. And there are generally 2 sort of barriers to improving probability assessment. Basically, through learning. What that means is, so supposedly people could learn and improve their assessment. Even their initial assessment are poor. Okay, so suppose you after you graduate, you go to a company. This company, what you do is you have to decide on how many stock this company have to buy each month. Okay, but initially you don't know about the demand. You have a very poor estimation of demand. You don't have any experience about this on this job, so you might give very poor assessment about the probability of a high demand or low demand, right? But in the long run, you should be able to learn from your past experience and history of your past, right? And then you correct for your assessment. Now, when the new months come, you should be able to give a better assessment than what you did initially. That's what you mean by through learning. So improving probability assessment through learning. But there are two ways that this could not happen. Okay, one is called confirmation bias. Okay, so this is like I think the best example is like I think in politics. Okay, so for example, I don't know if you guys know this, but in the U.S. For example, the Fox News is a news channel that support President Trump a lot. And some other news like CNN, which Trump basically shouted at a lot, is a channel that's sort of against Trump. Okay, so more Democrat, and Fox is more Republican. Sort of, not really true, but generally speaking, yes. And if you are a Trump supporter, if you watch the Fox News every day, or if you're a Democrat, now it's who Biden, okay, Biden supporter, and you watch the CNN every day and watch the news that support Biden or Democrat in general all day long, you sort of learn to see for confirmation evidence. Okay, you sort out to seek for information that confirm your initial belief. Okay, so for example, you believe that Trump is good, and then you keep watching this Trump is good news. Even if Fox News actually occasionally have a news that doesn't really align with what Trump said, but you will sort of ignore that news. That's what I mean by confirmation bias. Okay, this is actually very common, not just in politics, but in general. In company, like if you keep doing making the same judgment, and you think you're good, in reality, you might be making good estimation 6 out of 10 times, for example. But in your imagination, or if I ask you to recall, you might say that, I'm 90% correct. The reason why is that you can more easily recall your memory when you are successful. So that's called confirmation bias. Okay. And the other is called hindsight bias. So this sometimes a little bit mixed. So confirmation could be something you go back, but that's why sometimes it's mixed. But hindsight bias is sort of this is as the name suggests, right? So after you make the decision and you came back and say, what I did was so accurate. Okay, I don't know. In Chinese, it's called 后见之明. Okay, so people in Chinese, if you know that word, that should directly understand what I'm saying. But so you look back and think that our prediction were more accurate than they actually were, basically. So in this case could also not be exactly prediction, but something that you were actually incorrect, but you thought it was correct. Okay, so the example I give in the confirmation bias, the last one, is closer to hindsight bias actually. Yeah, that was the question, or no?
Yes, I didn't really understand the difference between the confirmation and the insight.
Okay, so it's more like a time domain issue. Okay, so confirmation bias is more like everything is right now. You will, first of all, you will seek out for information that agree with what you thought you believe in at this moment, and you will tend to ignore evidence that's against what you believe for now. Okay, and hindsight has a time domain which talking about now and the past, or future and now. So if I go to the future, after I make this decision and then I look back, I would thought that I make a better decision or a better assessment, better something. Confused. Which part? Hindsight bias. So, give an example that you think is hindsight bias, or you think close to what I just described, and I can tell you are correct, or tell you which part you maybe a little bit depart. No? Okay, so take your midterm as example. After you finish your midterm, okay, I didn't give you back before I give you back your midterm, if I ask you, like, how were you doing? On average, our class will report that maybe their average is 70. And after I give you back, it's more likely to be lower than 70. That's the hindsight bias, basically. Yeah. Here, I'm taking the assessment as a actual number, but if it is a probability, it's the same thing. You basically think you are more accurate than you actually were. Okay. Is that clear? Yes.
So when hindsight bias, like you already made a decision, but if you go back to your first decision because you think that your first decision is better than your.
You say first decision, but there's only one decision basically.
So hindsight bias, like you change to go back to your.
So like I said in the midterm example, you didn't make a new decision. Right? I asked you to estimate or tell you how good were you in the midterm. If you don't really remember, your memory will guide you to think that you do better than you actually were. Is that clear? Okay. So, I already talked about direct assessment and indirect assessment last time, right? But before that, actually, there's a general process, I guess. So, for you to do a probability assessment, you want to do the following three things. So, this is what the textbook suggests. Okay. So the first one is motivating. Basically, you want to explain to yourself, your assessment, you assess yourself, or the decision maker that you want to help, the importance and purpose of the task. So like the question asked today about the sensitivity analysis in the assignment 2, in that case, the probability that you assess doesn't really matter, right? Whatever probability you assess, the result will give you the same decision suggestion. In that case, it is not important. But in most of the case, the probability that you assess for a specific event should be important, and the importance of it can be told by sensitivity analysis. For example, if this guy tell you, I think it doesn't matter what my probability assessment is because I think it's around 0.5 to 0.7, for example. And so it doesn't really matter. But if your sensitivity analysis tell him that the cutoff point is 0.6, then actually 0.5 or 0.7 make a big difference, right? So that's how you sort of motivate other people or tell people why this is important. And structuring means that you want to ask people the precise question. So you don't want to ask people question like, what do you think about next year's U.S. economy? Which is actually not U.S. economy, but economy in general is what I got as a question when I tell other people I'm an economist. For example, in a taxi, the taxi driver asked me that. And that's a very unclear question. Okay, this economy has very, very different domain and different prospect. So you want to ask, for example, you can ask, what do you think will be the U.S. stock, for example, NASDAQ index next year, today, at the end of the market, or at 10 o'clock in the morning, something like that. That's a very specific question, and you can have a very specific answer or very specific probability. Or you don't want to ask what is the probability that next year the U.S. economy will be good. Okay, first you need to define good. That's a different issue. But even if you can define good, like a year's economy sometimes is good, sometimes bad, right? So how to really define the probability here is a big issue. But if you define, say, what is the probability that this Friday the NASDAQ will reach some specific number, if say, I don't even know what NASDAQ is now, but say 10,000, something like that. Reach 10,000. What is probability that? So that is gonna either happen or not happen. So it's a very clear defined probability. So ask your question clearly. That's what I mean by structuring. Okay. And conditioning is something like you want people to avoid confirmation bias, hindsight bias, or any kind of behavior heuristic that people tend to employ in general. Okay, so all kinds of bias. There's too many biases, so I don't want to go by them one by one. Okay, but generally speaking, you want to in specific scenario, you need to know what kind of biases is more likely to present and try to avoid those. Also, like when you are making your own life decision, so suppose you're a graduate, you're going to a new school, or you're going to work, which company do you choose, something like that, like a big lifetime decision, at least for your age. You should, take these biases into account, that understand that you yourself could have these kind of biases and try to avoid them, intentionally. Okay? And we talked about this direct assessment method last time, just ask people the probability, but obviously there is some issue. And I talked about the probability wheel last time, the indirect method. Do people remember this? So this is basically, you give people this wheel, okay? And suppose the red color here So the red color here has a probability of 28%. And the question you ask people is choosing between two lottery. One lottery is if the index, the pointer here, is randomly, what's that called? Reverse, or sorry, spin, yeah. Spin on this wheel, and then it reaches the red zone. Then you will get, say, $10,000. Or another lottery is a specific event. If a specific event, say event A, would happen, so with probability PA it would happen, you will also get 10,000. Or with 1 minus PA, you will get nothing. And here is also, if you in the red zone, you get 10K. If you're in this zone, you get 0. Okay. So between these two lottery, which lottery do you prefer? If people prefer this lottery, it means probability A is greater than 28%, right? Because it's more likely to happen, so people choose that lottery. So it means that you need to lower A. Because you only know that Yeah, lower A. You know that PA is greater than 28%, but you don't know how low. Greater than 28%. Yeah, it's greater than 28%, but you don't know whether that's 29 or 20 or 30, right? Or it could be anything. So you want to lower it so that people would actually say that they are indifferent between these two. Then that's the probability that you should choose. That's the probability assessment that you get. The reason why this is called indirect is I didn't directly ask you. I use a sort of secondary method to ask you. Do people get why this is indirect? Yes?
Why do we have to lower 28%?
Okay, so okay, so maybe lowering 28% is not a lowering. Sorry, did I say lowering 28%?
Yeah.
Sorry, I said it incorrectly. So I was thinking about lowering A, but you cannot lowering A, so it's actually increasing 28%. Yeah, so increasing 28% so that you matches each other. But the idea is the same. You need to match when people say they're indifferent. Because here, you only know that PA is greater than 28, but you don't know how high, right? So you keep raising 28%. So you raise it to 30, raise it to 32 until it matches each other, basically. Okay? Yeah, good catch. Yeah, sorry. Anything else? No? Did I talk about this last time? No? Okay, okay. So assessment method for probability distribution. So sometimes you don't want to ask for one probability, right? You want to ask for a distribution. Like for now, people should be able to understand the difference between just one probability and distribution, right? They're very different things. Do people understand what I'm saying? The difference between this, there's only one event. Probability A either happen or not. And what it means by a probability distribution, there are two different things in general. Do people understand what I'm saying? Yes, okay, good. So, I think I did go through this, but anyway. So you want to first decide and revise the possible range. What that means is a distribution has a minimal possible value and maximum possible value, right? That's called the range. You want to first know the range. So you basically ask people about the range and then talk to these people and seek and think about whether this range need to be revised. It need to be a shorter range shorter range or a larger range, longer range. Okay. And then you ask for the CDF. CDF is the cumulative distribution function. Okay, so you basically ask this person so what is the probability that, suppose the random variable that you're interested in is how much money you will make at the end of the year. You ask question how much, what is the probability that our company would be able to earn $10,000 or less at the end of this year. And then you ask what's the probability that's less than or equal to $20,000, but greater than, or less. Something like that. You gradually ask them and then you will get a CDF. And then you will fit a curve that usually you don't really do that by hand, you use a software to do that. And then basically up to this point you already finished. Step 4 and step 5 is a checking, basically. checking this for you to make sure your result is coherent. Okay, so you want to, so suppose your range is $0 to 100K. Okay, and your distribution looks like this. This is a PDF, not CDF, but after you have a CDF, you can easily convert it to PDF. Okay, this PDF is not the file extension. Okay, it's the probability distribution function. Okay, so this is easy. So you get this, and what it means here is that you sort of draw two lines so that this area is equal to this area and equal to this area. So area 1, 2, and 3 all equal to each other. Okay? And then you ask the decision maker or ask yourself whether these three range are happen with equal probability, whether that makes sense or not. That's one check. The other check is to make sure that the mode makes sense. For those who don't remember what's mode is the most frequent event in a distribution. Okay, so usually in a bell curve, the mode is equal to the mean, equal to the median. But for example, if you have a distribution like this, then you have two mode because they both happen with the highest chance. So usually you want to have a single peak distribution, but that's for mathematical reason. But in reality, you could, you rarely get a double peak because it's really unlikely that you will really get two equal height. But if two height are very close to each other, you consider them as two mode. Okay. So after you see the mode, you also ask the decision maker, ask yourself, whether these modes make sense or not. Whether these happen with the highest, chance in the population, whether that makes sense or not. For example, if you do a probability distribution of the height for the first grade student in your own country. Okay, you should be able to know better in your own country, right? So, and you see that the mode somehow lie in the range of 160 centimeter to 170 centimeter. You must be wrong, right? Your first grade cannot be that tall. Okay, so you need to revise the previous step, something like that. Okay, so we'll come back in 2 o'clock.